All right, in this example, we're given a rate of change function. We're told that f prime of t is given by 0.82 to the t power. We're also given some information about the original function. F of 2 is equal to 9. And we want to complete the table of values for f of t. All right. Well, right off the bat, we know f of 2 is equal to 9, so we can fill that in. Now, in order to find the other values, what we can do is use the fundamental theorem of calculus, right? So if I want to find f of 4, I know that the integral from 2 to 4 of f prime of t dt is equal to f of 4 minus f of 2. Okay, and I'm given f of 2. So let's rearrange this. I can solve for f of 4 is equal to f of 2, just adding f of 2 to both sides, plus the integral from 2 to 4 of f prime of t, which is, and actually why don't I just actually put that in there, f prime of t is given to be 0.82 to the t dt. All right, now we have to find this integral, and you haven't really learned any integration techniques yet, other than doing it by left and right hand sums, or doing it on your calculator. So I'm going to just do this on my calculator. Okay, so I'm going to use my calculator. I know that f of 2 is 9. If I plug this integral into my calculator, I get 1.11. All right, so that's telling me, again, just using numerical integration techniques on my calculator. Again, because I could do this, like I said, I could do it using right or left-hand sums. But essentially, that's kind of what your calculator is doing. It doesn't have a way of integrating other than integrating numerically. Okay, so I get 10.11. Okay, just using my calculator. All right, so we can keep going. We can find f of 6 in the same way, right? We can say that f of 6. I could do a couple of different things. I think what I'll do is just start with, I forgot f of 4, so I'm just going to take f of 4 and add the integral from 4 to 6 of this 0.8 to the t dt. Okay, so I've got f of 4 is 10.11, and then I'm going to add the integral that I evaluate by putting this into my calculator. Seems like cheating, I know. But all right, that's what we're going to do here. So when I add that on, I get 10.86. So I can fill in that data point in the table. All right, and I'm just going to do the same thing for f of 10 and for f of 20. So I'm just going to take f of 6 and add the integral from 6 to 10 of 0.82 to the t dt. Okay. Now what I got when I did that is 11.7. And then for f of 20, I'm going to take f of 10, and add the integral from 10 to 20. 0.82 to the t. Again, just using my calculator. And I get 12.29. All right, so let's put that over here. 11.7 and 12.29. All right, that's just using the fundamental theorem of calculus and using my calculator. All right, now one question I could ask is, can we find f of 0? So it's a little bit different because now we're kind of working backwards. I just think this is kind of an interesting question. Can we find f of 0? Well, I know that f of 2 minus f of 0 would be the integral from 0 to 2 of 0.82 to the t dt. So if I rearrange that, I would get that f of 0, okay, this adding f of 0 to both sides and then subtracting the integral. So I end up with f of 2 minus this time integral from 0 to 2 of 0.82 to the t dt. And again, I can put that into my calculator. I'm going to get 9 minus the value I get by putting this in my calculator, which I got 1.65. So if I wanted f of 0, it would be 7.35. Didn't ask for that. I just think it's interesting that you can, you can work forward from an initial condition, or you can work backwards as well. All right. So I'll meet you in the next video.